The first lesson of the next semester has to do with roots, radicals, square roots, other roots. So when we see this word real, roots of real numbers, roots we're going to kind of rephrase with the radical symbol. This is a symbol that's used to denote just any root. It doesn't have to be a square root. You've seen that symbol before, but if you make it a little bit wider and put kind of an unknown here, you have what could be construed as a third root. For instance, the third root of 8 is 2, because 2 cubed is equal to 8. This little box right here is called the index. It tells you what root you're taking. The thing inside is called the radicand. And oftentimes you talk about an invisible or maybe very visible coefficient sitting in front of it. So if I have something like 2 times the fifth root of 3, we have a coefficient of 2, an index of 5, and a radicand of 3. It's also worth noting that you do have an ability in your head to approximate radicals. If I asked you what radical 26 is, I wouldn't expect you to know its decimal value, but I would expect you to know that it is in between radical 36 and radical 25, probably closer to radical 25. So I would want you to know that 5 is less than root 26 is less than 6, which would make root 26 be about 5 point something. What is the square root of 26? I'm asking Siri. And it's about 5.1. So that's about what we'd expect. So don't go completely calculator crazy on this. A lot of times we have multiple ways to try to approximate what these things are. For instance, if I asked you to simplify root 50, this is kind of a review problem from Algebra 1. What I do is identify the perfect square factor of 50, which is 25. Take the square root of 25, which I can use the property that the square root of 25 times 2 is the same as the square root of 25 times the square root of 2, and I get 5 times the square root of 2, which may not seem very valuable, except that if you knew, as you will know, that radical 2 is about 1.4, then you can get an approximation for this by just multiplying it by 5. This is what they would have done in days before calculators. You had tables of values of radicals, and you would use those to approximate these values within a pretty decent degree of accuracy. So in any case, let's go to another type of problem where I ask you to solve x squared minus 50 is equal to 0. This is a very similar problem to what we just did, except that when I solve that, I get x squared is equal to 50. And there are two possible solutions. X would be equal to the plus or minus square root of 50, which we would simplify to the plus or minus 5 times the square root of 2. So there's a distinction between these two problems that we really need to discuss. The principal square root the principal square root, when I use that, I use this symbol, is the positive one. So it is actually true that every number has 2 square roots. You can even expand that, and this is crazy, that every number has 3 cubed roots and 4 fourth roots, but only one of them is principal. So when I say the principal square root of 5, well, the principal square root of 5 is this. It's denoted as radical 5. The other one is negative root 5. So the radical symbol, when used as a square root or any even root, means positive. Now, when it's used with a negative and with an odd index, like the cubed root of negative 27, the cubed root of negative 27 is negative 3. That just means the principal cubed root, which is just, again, a negative 3. It's a simplistic one to do a cubed root. And this is because negative 3 cubed is negative 27. Let's kind of move on and talk about a few more. When I have the square root of 3 squared, then we're going to do the square root of 85 squared. the square root of negative 3 squared, and the square root of negative 85 squared. I should be able to burn through these really quickly. This would be 3, this would be 85, but wait a minute. If I follow the order that it's given me, the square root of negative 3 squared is actually just 3. And the square root of negative 85 squared is actually just 85. Something is going on right here. What has happening is that the squared power is destroying the negative, and we never get it back. This means that this and this, square rooting and squaring, are not perfect opposites of each other. They don't actually undo each other completely. It really does depend what's going on. So when I ask this question, and we're going to ask it frequently this semester, what is the square root of x squared? This is not x. It's close. It is also not plus or minus x, because that would be two outputs for a function, the function being the square root, and that wouldn't work either. I need an operation that, if I look what's happening here, 385, 385, my outputs are always positive. The square root of x squared is identical to the absolute value of x. Let me show you what I mean in a different way. I'm going to give an example where I take x squared is equal to 49. And I'm going to solve this by putting a radical symbol on both sides. Well, the true value of the left side is absolute value of x, and the true value of the right side is 7. So the absolute value of x is equal to 7, which means that x is equal to plus or minus 7. And I'm willing to bet that you've never seen it this way. So this has far-reaching consequences of things like this. When I take the square root of x squared plus 6x plus 9, and I would write that as x plus 3 squared, square rooted, the value of this can only be simplified to the absolute value of x plus 3, not x plus 3. This can actually get a little bit trickier, because if I do the cubed root of x minus 7 cubed, well, that is actually just x minus 7, because it's a cubed root. We can take cubed roots of negative numbers, and raising a negative number to an odd power keeps the negative. The cubed root of x cubed is x. The fourth root of x to the fourth is the absolute value of x. Something is going on with the odds versus the evens. Odd powers love negatives. Even powers destroy negatives. This is going to take a little bit of time to work through. The idea that the nth root of x to the n is x when n is odd, but it is the absolute value of x when n is even. So wrestling with that for a little while, the difference between the 71st root of x minus 1 to the 71st versus the 72nd root of x minus 1 to the 72nd. The left one is just x minus 1. The right one is the absolute value of x minus 1. So given this, this is actually going to make the next assignment be a little bit more complex than you might think it would be. If I take the cubed root of x to the 9th, I not only need to think about what multiplies by itself to get to the 3 times to get to x to the 9th, that is x to the 3rd, but I need to check the signs here. So we're going to check if x is negative. So if x is negative, and we're going to check it right here. If x is negative, I get a negative to the 9th cubed rooted, and that is a negative. Then we're going to check the same thing here. Check if x is negative. Or I shouldn't say if, I should say check when x is negative. When x is negative, here I get a negative cubed, and that is also equal to negative. And so, bingo, they match. Let's try this with another one so you can get this idea going down. Let's do the cubed root of x to the 6th. And we're going to check when x is negative, I get a negative to the 6th power cubed root. A negative to the 6th power is a positive number, and the cubed root of a positive is a positive. Then I'm going to simplify this. The cubed root of x to the 6th is actually the same as the x squared, 6 divided by 3. And when x is negative, I get a negative squared, which is also a positive. They match. You may be asking, what happens when they don't match? So let's do the square root of x to the 6th. Okay, I'm going to write this out again. When x is negative, I get a negative to the 6th power square rooted. That is a positive. Now we're going to take the square root of x to the 6th, which is x cubed. And when x is negative, I get a negative cubed, and that is a negative. They do not match. So to force, I can't make the positive be negative, but I can make the negative be positive. What I can do is do an absolute value, which I really should simplify to the absolute value of x cubed. So that is true. The simplification of the square root of x to the 6th is the absolute value of x cubed. Again, a little trickier than you may have wanted to. So I'm going to go through this process one more time. Cubed root, x to the 15th. I'm going to simplify it, get x to the 5th. I'm going to check when x is negative, I get a negative to the 15th cubed rooted, and that is a negative. Then I'm going to check it here, negative to the 5th power, and that is a negative. And they match. So I don't need to do anything to fix that or change it. Okay, new problem type. Solve. We're going to solve for x squared plus 14x plus 49 equals x plus 7. I want to figure out, when is this true? Well, to solve, we want to simplify the left side and the right side, and I can actually simplify the left side. I can make this, factor this into x plus 7 squared, square rooted, and x plus 7 squared, square rooted is the absolute value of x plus 7. So I have the absolute value of x plus 7 equals x plus 7. And there's a neat trick that pulls on stuff we did last semester to figure this out. I'm actually going to determine where the critical value is and do a sign test on this. Critical value is -7. I'm going to plug in -7, and actually -7 will work. It will give me 0 equals 0. I'm going to check numbers to the right of -7, like maybe 0. So if I test 0, I get positive equals positive. That works. So I'm just going to shade this here because I know that any number right of 7 is going to satisfy this. And if I check maybe -6, I get a positive, let's see, oh no, not -6, sorry, -8. I get a negative in absolute value equals a negative, which means a positive equals a negative. And that is out. That is not true. So really my solution is all x such that x is greater than or equal to -7. Number 14. Cubed root of x minus 1 cubed equals 1 minus x. Okay, we're going to simplify the left side. Cubed root of x minus 1 cubed is not the absolute value of x minus 1, it's just x minus 1. So I have x minus 1 equals 1 minus x. Well, we can actually solve this. We don't actually need to do a sign test. 2x is equal to 2, and x is equal to 1, so my only solution is 1. Let's do one more. Let's do the square root of x minus 7 squared is equal to 7 minus x. So on the left side, I get the absolute value of x minus 7. On the right side, I get 7 minus x. And to do this, let's try the critical value method again. Critical value is 7. And I know 7 is going to work. So now I'm going to check maybe a number greater than 7. Let's check 8. When I plug 8 in, I get a positive equals a negative. That's not going to work. Let's check 0. When I plug 0 in, I get a positive equals a positive. That works. So I know that my solution is all x such that x is less than or equal to 7. And we're done.